So here we go. Circles, circles, circles. We got circumference and area of circles. So we're going to be talking circles today. So here we have a circle, and really there's 5 things I want to talk about. I want to talk about circumference, area, and that's the title of the video. But the behind the scenes quantities I want to talk about are the radius, the diameter, and pi. So those are words you might have heard before, but we're just going to cover them together. Okay? So here, if we want to talk about going from one side of the circle, crossing through the center, and going to the opposite edge, we call that the diameter of the circle. And this is often quoted for all different kinds of products in real life. Now, another quantity that can be quoted is only going halfway. It's going from the center to the outside edge of the circle, and that's called the radius. So we use R to symbolize radius, and we use D to symbolize diameter. Okay? Now, we use these quantities really to find circumference and area. So the idea of area hasn't changed. It's like if I wanted to find the amount of two-dimensional space in here, the amount of carpet I'd have to lay in the circular place, the amount of mulch I'd have to lay down in the circular garden, whatever the case may be. If I want to find the area, this is the inside area of the circle, okay? The area enclosed by the circle. Now here, circumference is a big long word, but all that means it's the perimeter of the circle. So again, it's like perimeter and area. Now the perimeter has a special word, circumference, and that's only for circles. So here the circumference of the circle is how far around you go on the outside. So again, that's like walking around a track, walking around the outside of a circle, however you want to phrase it. Now, the mysterious thing that we've not talked about yet is pi. Pi is this number here, 3.14159, and then goes on and on and on forever. It's actually in a class of numbers called irrational numbers, and that means they go on forever and don't repeat. Really quite interesting, but we're not going to talk about that too in depth today. What we're going to do is say 3.14. Well, after that, that's a 1, and that's in the thousandths place, so a good approximation for pi is going to be 3.14, and this is something you might have been told before. Pi is 3.14. Actually, it's a little bit more than that, but not a whole lot, so we just run with 3.14, and that's what we'll be using as our approximation today. Now, pi is the ratio of the diameter to the circumference, and you see this right here in the first equation we want to look at. So this equation right here, circumference is actually just pi times diameter. It's the ratio between them. So here, pi times diameter will get you the outside circumference. Now, because the radius is only halfway, you'd have to multiply the radius by 2 to get the diameter. So if you were given the radius, you just actually want to multiply that by 2 and then multiply by pi. So that's why the circumference is 2 pi r. That 2 meaning that I need to double the radius to get the diameter. Okay? And then for the area of a circle, area is over here, and it's equal to pi r squared. And people come up with all these phrases and catches. Pi's are square, pi's are normally round, stuff like that, but really it's just pi r squared, and you'll want to commit that to memory. It serves you well. So here you just have to take the radius. So for instance, if I was given the diameter, I would have to cut it in half. I would have to divide by 2. Alright, so let's go ahead and work some circumference and area problems. That sounds like fun. So here I'm going to throw some circles up, and we're going to work them out. So here, if I want to find the area and the circumference of this circle right here, this bad boy, this is actually made by a cup, and the radius of the cup is 2 inches. So let's find the circumference first. Well, circumference is equal to 2 pi r if I'm given the radius, and I'm given the radius here. So I'm going to just plug right in. C is equal to 2, which is a constant that does not change. Pi is 3.14. Again, since I'm substituting in, I'm putting in parentheses around it to show multiplication. And then radius, the r is 2. In this case, inches. Okay? Now here we go. In this situation, I feel okay using a calculator just because it speeds things up, and we're not really testing you on your multiplication right now, although we could be. So it's up to your test or your teacher or whatever you're doing if you want to use a calculator or not. In this case, I'm going to speed up the video and use a calculator. So 2 times 3.14 times 2, that is 12.56. So I can say the outside edge of this cup is 12.56 inches around. And I just take that inches and bring it down with it. Because this was in inches, the circumference is in inches. Okay? Now here, let's do the area. So the area, I'm going to write that underneath it with an A. And I'm actually going to switch to an orange marker. That'll be fun. So A, I'm going to write that A again. Oh, that's so bright. Oh, okay. This is going to be pi r squared. Okay. So area is equal to 3.14. Again, I'm substituting in. And then that's equal to a 2 inches squared. So now area, I take my handy dandy calculator again. I'm going to say 3.14. And now I'm going to multiply by a 2 squared. And I have a squared function on my calculator. If you don't, you'll have to remember that squared means it's multiplied by itself. So that's really 2 times 2 or 4. So I could actually take 4 times 3.14. But here, my calculator is a function. So again, the area, fascinatingly enough, is 12.56. That's quite fascinating. That doesn't happen very often. Barely ever. 12.56. And this is going to be inches squared. And that's because these inches are inside these parentheses and I square them. So if I square inches, I get inches squared. And that makes sense because it is an area quantity. It tells us the amount of area. Just how you would want to find square footage. If you wanted to carpet your room, you need square units. So here, let's work the next one. Let's pretend this is a circular garden and the diameter across is 7 feet. So here, what we have to do first is circumference. And this is actually a little bit easier. It's just pi times diameter. And then so that is 3.14 times 7. And then we're just going to work that out on the calculator again off screen. 3.14 times 7. Feel free to do it with me. 21.98. So 21.98. And then I forgot to mark feet here. But this is feet. Feet here. Just make sure when you get to the end of your answer, you always quote the units it's in. Just be careful on that. And now here for we just said circumference. Here for area, we got to work some magic out because area is pi r squared. I don't have the radius. What do I do? Well, we'll have to divide the diameter in half, like so. So here, 3.14 times 7 divided by 2, because it is the diameter, squared. So to work this out, if your calculator doesn't have that functionality, you'll have to divide 7 first, and then square it, and then multiply, in that order. But if your calculator has the functionality of modern calculators today, oftentimes you can do it all at once. So here, working it on my calculator, I get, one second, I get 38.465. So 38.465. And this is again going to be squared units. In this case, it's feet. And there we go. It's feet squared. So 38.465 feet squared. And again, right here, the circumference and area are different. That was just quite fascinating that the last one, because the radius was 2, it worked out to be the same. And that's only specific for that number, so that's interesting. But here, I hope everyone enjoyed the video. If you have any questions about circles, anything at all, just shoot me an email. Thank you.